Okay. Hi everyone. Today I'm going to be looking at differentiation and how it applies to something we call polar coordinates. Now, up until this point we've been looking at functions that are y with respect to x or some combination of x and y. Today we're going to be looking at these particular ones because they have particular properties we need to think about when we're calculating. So if you recall, polar coordinates is a way of expressing a point in terms of both sine and cosine. So in this example I have r on my sort of polar coordinate gram, and we have x and y being a function of some trig function. Now that's generally well and good, but when we get to differentiation, we now have two equations we need to think about. So what I've done is I've written out four strategies, four steps that we can take to make sure we stay on track. So the first one is, with both equations, we need to differentiate with respect to the angle. Now in most textbooks you find it called theta, you might find it called anything else, but the main thing is we need to differentiate with respect to that. The second thing we need to do is we need to use our algebra to manipulate the equations that come out so that we find the correct relationship that we need. For the most times we need dy by dx, but it may be something else, depends on what your needs are. The third thing we need to do is we need to use our trig identities to simplify. And the last thing we need to do is we need to evaluate if it's required. So let's go and have a go at one simple question. It's an example that we can apply our strategy to. If x is equal to secant theta and y is equal to cos theta, find dy by dx when theta is pi over 3. Now what I like to do, as I've done here, is I like to draw out the angle that I'm working with, just to keep an idea of what numbers I should be working with. Now pi over theta is going to be in the first quadrant, which means both the x and y values are positive. I then quickly sketch it out. I know pi over 3 is about 60 degrees. And actually it is 60 degrees, so I just draw that out, and I know that this is going to be the shortest side, which is going to be 1, this is going to be the longest side, which is going to be 2, and then the third side is going to be root 3. Now, again, according to our strategy, the first thing I want to do is I want to differentiate both of these equations with respect to theta. So, dx over d theta, well, from last week's lesson, we realized it's just secant theta tan theta. We differentiate y with respect to theta. We have dy by d theta is equal to minus sine theta. So that's our first step. The next thing we need to do is we need to use our algebra to find our derivative. In this case, we're looking for dy by dx. If I looked at this, I can see I have dy by dx is equal to dy by d theta. If there was some way to cancel the d theta, I would have my dy by dx. If I flip this over, that's what can happen. So dy by d theta by dx, let's cross this out, will leave me with this. So that's what I'm going to try and do. So dy by d theta, well, that gives me minus sine theta. I need to flip this over, so it becomes 1 over this value. Okay. So that gives me the equation for dy by dx. Now the next thing I need to do, according to our strategy, is I need to simplify this. I have 3 trigonometric terms. I would like to have just one. So I'm going to use the trig identities that I know to see if that will help me cancel out some of these. Well, secant theta I know as 1 over cos theta, so I can rewrite it like this. And tan theta, well, I know that's just sine over cosine. So I can write this like this. Now I can flip these. Now I have just 2 trigonometric terms, and this one will cancel out with this one, which leaves me with just one trigonometric term. Now the last thing I want to do is evaluate where it's required. And I know it's required because I want to find the value when theta is pi over 3. So if I do a quick check, pi over 3, cos of pi over 3 is going to be 1/2. So I need to plug this in. And make sure that we don't forget our minus signs. So this is out here. And there we have it. dy by dx is equal to minus 1/4. So our strategy helps us a lot in just staying focused and working through the steps. So just to recap, to work with differentiation and polar coordinates, we need to differentiate both sides with respect to the angle, use algebra to find the derivative we're looking for, use trigonometric identities to simplify, and then finally evaluate where it's required. Thanks for listening, and I'll see you next time.